A warm welcome to all for the DC Machines and Transformers Laboratory through this short video lectures. So I will give the instruction for the load test on DC compound generator, right? So in this experiment we are going to study about the operating characteristics of the DC compound generator in two modes, cumulative compound generator mode and as well as differentially compound generator mode. Once you enter into the laboratory, you need to go for the bed number 7, where we are going to carry out this particular experiment. And in that case, you need to record the nameplate detail of the prime mover as well as the generator. So both you need to record in this table, and after that you need to design the equipments or apparatuses required. For example, what is the fuse rating required, what is the field rheostat required, and shunt field ammeter, what is the rating required, field ammeter required, and what is the voltmeter required. All those things you need to record, you need to design it, and what is the line ammeter you require, and all these things based on the nameplate details. You need to do a small note here, and after that you need to get the signature from the faculty, and once it is completed you can give this filled sheet of name of apparatus and specifications quantity to the technician, and he will provide the components whatever you requested. And now you can do the connections. While doing the connections, your connecting part starts from this particular point, and before that everything is internally connected. So from this point you need to connect up line wire to the L point of the 3-point starter, that is line point, and F of the 3-point starter should be connected to the fixed terminal of the field rheostat, and the variable end is connected to the Z terminal of the shunt field coil of the prime mover or motor, and the other end of the field coil ZZ will be connected to the AAA, and one more wire is connected from ZZ to the negative side, so that this part is completed, this cycle is completed. And this side from A, motor terminal A, armature terminal A is connected to the starter A terminal A, and now this prime mover part is completed. And now you can move to the generator part, where here this A and Y you need to connect with the wire, and YY is connected to the DPST terminal, and the same YY is connected to the fixed terminal of the rheostats, and the variable terminal of the rheostat is connected to the shunt field coil terminal Z, and the ZZ of the shunt field coil terminal should be connected to the positive of the ammeter, and the negative of the ammeter is connected to the armature terminal AA, and one more wire from the negative of the ammeter to the DPST, right? So now across this DPST you need to connect an voltmeter. Positive is from the input of the DPST, and negative is also the other terminal of the input of the DPST. The output of the DPST is connected via a fuse wire and to the positive terminal of the ammeter, and the negative is connected to the load terminal. The other side of the load terminal is connected to the other end of the DPST output. So now by the time you completed all the connections, now you can go for the procedure. So that is how to perform the experiment. So for that we already gave the set of procedures. So first you need to close the precautions as already told in other experiments. Field rheostat, motor field rheostat should be minimum, generator field rheostat should be the maximum, and the DPST should be in the open condition. So these are the precautions. Now I already connected the connections. So now supply is given to this side, and DPST is closed. So DPST switch is closed. The prime mover DC motor is started with the help of 3-point starter. So by adjusting the 3-point starter we can start this motor, and now prime mover speed was adjusted with the help of this prime mover field rheostat such that this motor operates at the generator rated speed. So once again you need to adjust the motor speed to the generator's rated speed, right? At that condition you can take the no load voltage, whatever the voltage you can read here can be recorded in this table, and then generator side DPST is closed. This DPST is closed. This DPST is closed, and load resistance is increased in a step-by-step manner by varying the load, respective load voltage, and line current and the field current. Everything was recorded, and for that you can go for this particular table: load current, field current, and voltage terminal. Now the thing is, for every increasing of load, if the current value and voltage value increases, that means you see this model graph. So here the generator voltage increases slightly, and for every increase of load current. So that if your generator performs in such a way, that is the meaning of that you are connecting in the cumulative compound. So right, so you are connecting in the long shunt cumulative compound. Suppose for every increasing of resistance or load, if your current is decreasing, means you are connecting in the differential mode, right? So that is what is the understanding. After completing one particular mode, that means you are completed the cumulative mode, means to perform in the differential mode you need to reverse this terminals. So just by instead of Y you need to connect the YY, and this should be here and this should be here. In such a way you need to reverse it for other combination, that is differential combination, right? So now the increasing of loads should be carried out till this ammeter reaches the rated current, and that should be recorded, right? Finally the load is decreased gradually and brought to the initial condition, and the supply is switched off, right? So first the DPST should be open, and the primary side DPST should be switched off, right? The same procedure can be repeated for any type of combination, that is long shunt, short shunt also. So instead of this connection, if you connect here, means that is short shunt. So in such a way you can modify anything, but in this experiment we will do for this for both long shunt and cumulative and differential, right? So all these things you can record here. In long shunt, differential, cumulative, both can be recorded, both can be plotted, and the conclusion can be written, right? So hope with this you can easily perform the load test on DC compound generator, right? So thank you, thanks for watching.